wabarakatuh. My name is Nur Hidayah binti Musa and I'm going to present the project which is the hardware development of the IC tester for digital logic gate. But before I start, I would like to thank Mr. Fairuz and Dr. Jamil who had given me a time and a consideration toward my presentation video. So let's get started. First of all, I would like to explain the description and the purpose of my project. Basically, the purpose of the IC tester project is to easily check the logic gate IC condition within a short span of time. It is to check whether the IC is a good IC or a faulty IC. The logic IC functional tester project is to construct a simple and inexpensive system which is suitable for the testing function of a small-scale chip. The project feature for this final product is the packaging box. The box has length of 20 cm, a width of 30 cm, and the height is 8 cm. The circuit on this final project is used by the PCB board. It consists of 2 push buttons, 1 diff socket, 1 LCD, 1 variable resistor, and 1 switch. Moving on to the interaction of the project, which is this project is a digital IC tester is built to test a series of 40-pin IC. These are the basic logic gate common in electronics. Basically, the project can test for the IC gate such as AND or NAND, NOR, and the NOT gate. So, my objective of this project is to develop the digital IC testing hardware for the IC logic gate and to analyze the efficiency of the system for the selected IC. Moving on to the problem segment, which have faced some difficulty in troubleshooting. The problem can occur during checking of the source of error in the circuit. This is the common problem in the troubleshooting in the circuit. The problem also will lead the time waste, and we all know that troubleshoot in the circuit will take some time to find the source. So we can state here that it is wasting the time in finding the problem that's caused by the faulty IC. By right, the faulty IC is also lead to inaccurate result. The consequence of this wrong outcome contribute to inaccurate measurement and evaluation in the certain result on the data project. Let's move on in the methodology of this project. For this part, I will explain how the project flow based on the flowchart show. As usual, first of all, it will start. Then it will initialize the LCD at the input, which is the push button. Once the LCD initialized, the LCD will display the IC gate in current loading state for 3 to 5 seconds. This is where the controller starts to load the program. Once the program had been loaded, the LCD will display the input, which is the switch 1 and the option of the type of the IC. After that, the user can start to choose the IC based on the IC inserted. Then there is condition whether the user was insert the IC or not. If the user are not insert the IC and still continue to process the program, it will initialize the IC and send to the PIC. Therefore, the result state as the complete but is not working. This is happen because the PIC controller cannot detect the pin number on the ZIF socket. But if the user insert the IC and choose the IC type correctly, it will initialize the IC and send to the PIC. Then there is second condition, whether the IC condition is display test complete and the IC is working. Otherwise, test complete, the IC is not working. Therefore, the user need to choose the IC type correctly, and this is where the controller read the pin number of the IC in the ZIF socket. On top of that, the result for this project will show by the demonstration on the next video.
So this is our final product of the project that use of 3-pin plug and also for DC power jack of 5 volt. So we can connect it, and there is switch that can use and the variable resistor to adjust the brightness of LCD. This is the first switch to choose the IC, and the second switch is to process the IC. This is the ZIF socket to insert the IC, and the output will display on the LCD. And for the circuit connection, we use the PCB board and the jumper for the connector. To run the program, first we need to on the plug and the switch. And you can adjust the brightness on the variable resistor on the LCD. And then it need to wait for 2 to 3 seconds. And then you can start insert the IC. For this part, we need to carefully insert the IC in the ZIF socket. otherwise it will pop up like this. So we need to secure and lock the IC chip on the ZIF socket, and can press the first switch to choose the IC and the second switch for the process. So this is the process for the IC testing, which is based on the truth table. So it will start to process one by one, follow the sequence of the truth table. So as for the result, the all IC gate is working. Then we can move on to the next IC, and you can push the first button, choose the gate, and this is the NOR gate, and push the second button to process. As usual, it will check one by one, follow the sequence of truth table that have set on the program. And basically the NOR gate IC also is working, and we can continue for the next IC. This is for the NOT gate. Also the same, it will process one by one. And for the result is NOT gate is working. And the next gate we insert. Which is for the AND gate. Also we can check. And the IC gate for the AND gate also working. And for the last part, we cut the pin of the IC to check whether the IC is working or not. Supposedly the IC is not working since the pin number is not generated. So we insert the IC and we can choose the IC. So the IC gate is checked for the first one, okay. The second one, okay. The third one is error. And the last one is error. This shows that this gate is not working. So the output show on the LCD that the IC is error.
So based on the demonstration, we can analyze the efficiency and the accuracy of the project by making 5-time trial every each of the IC. This is where the table show the data recorded, and this is where the graph generated from the data that had gathered. Therefore, based on the data recorded and the graph show, out of 25 trials, there is only one failure in the output. As we have seen in the demonstration, there is part when the IC pop up when the ZIF socket are not locked correctly. This failure on the data might be the cause by the IC selected was not correctly inserted in the proper place in the ZIF socket. The input signal from the microcontroller will not correctly received by the IC selected. Because of this, there will be discrepancy on the result of the IC selectors, thus it will result to the failure. Based on the gathered data, it was concluded that the system has passed the functionality and the accuracy testing because of the positive result. By that, we can calculate the percentage of the error. The percentage of the error is less than 5%. The result of functionality testing had led to the conclusion that we can state that the efficiency and accuracy of the project is acceptable. Based on the project potential and commercialization, this project has the potential to be commercialized in the factory and or a laboratory, as it provides a low-cost instrument for the IC tester compared to the existing instrument available in the market. I have done my research that on the online market that has similar product which is 5 to 10 times higher cost than my project cost. Additionally, this project is portable IC tester offer a compact design, convenient and the time saving. Last but not least, this product can conclude that the effect of the wrong outcome contribute to inaccurate measurement and evaluation in the project. The main objective for this project is to develop the IC tester for digital logic gate is to help the student for troubleshooting in the circuit. So we can summarize that the development of our final year project had been successfully achieved. Thank you.